Hello everyone, today I am going to deliver a lecture on connection design. It will be connection design. So first part I will cover the beam column connection. Okay, connection design, the first part of the beam column connection design, and second part of column base connection design, which is base plate connection design. So let's start the connection design. Here is the connection design. You can see this is the first part, which is the beam column connection. So let's see. Now I'm reading the question first. If you want to see where is the beam column connection design, you just take a search on Google, then you can find the beam column connection. There's a lots of here. This is you can say this is the other example of beam column connection design in steel structure. So this is the portion we can see. Here is a column, here is a beam. So here is a column, here is a beam or girder. So let's see, here is a beam column connection design. Okay, select all boarded double angle connection, which is given in double angle. So let's see, between a W 1850 for beam and W 2180 girder. And supported with the following beam end condition. So this is not beam column connection design. It will be beam to beam design. The double-handed connection between it is given here. It will be beam to beam design, and then beam. I'm sorry for that. Beam to beam or beam and girder. Girder or beam or girder connection design. So let's see. As a between we have been seen, the floor beam is given 1850, and a girder is given a 2162 girder to support the following beam is reaction, and we have been seen the depth load is given here and live load is given there. The beam is flange kept 2 inches deep and 4 inches long, and LCB is given 1 into 4 by inches, and LCB is 1 into 3 by 4 inches. Use 3 by 4 inches diameter ASTM 36 inch nut bolt for standard holes. Beam are given 50 material. So we have been seen from beam, we have been shown here beam in W8015. So as the beam section is given, then we can find out easily depth, TW, wire thickness, and flange thickness, and K below from AIC mineral. If you go to the AIC mineral, this is the AIC mineral. W50, this is the W18 and 50. So this property. So depth, we have been seen the area is 87, and depth is 18. So depth is 18 is taken here, and TW and TF is also here. TWF is 0.335 and TF is 0.57. Here is a 0.57 and 0.335 and K below. All that is taken from AIS mineral. So these are given in girder to beam section. Okay. So beam bottom shall be, we have been seen the girder depth is 21, and on the other end, and the beam depth is 18. So between the gap between beam and girder, which is 21 minus 18, which is 3 inches. Yes, we have been seen in this figure. This is the 3 inches, and this is the girder, this is the beam. So 3 inches we have been seen here. so 3 inch is the bottom distance. Okay, so space available for bolt we have been seen 18 is given in the beam section. 18 minus 2 into 2 cb in minus into k value is found from ASM menu and found 12.53. And assuming the bolt spacing 3 inch, how will assume? We know that 3 into d is given 3 by 4 inch. Is question 3 by 4 inch is given in question, and found 2.25, which is greater is 3 is greater than 2.25, that's why you will use 3. And number of bolt available spacing have been found 25 12.53, and bolt spacing we have been 3 and plus 1, and which is found 5 bolt. So these are the arrangement we have been seen. This is the girder and this is the beam we have been seen. This is also beam, and the wall dimension is given, and we have been taken the 5 bolt, so we are using fiber 1 2 3 4 5 bolt. Okay, let's see the total load, dead load plus live load into 70. So allowable bolt shear capacity, a 32 bolt thread include in shear plate we have been used as we have been used LRFD, then it will be 0.75. If we use ASD, then phi will be 0.70, and m equal to 2 as we are using the double share, as double share we have been used, and mb equal to 0.40 into 120, and mb pi by 4 into d square by 4, which is the pi by 4 into d square, which is d is given 3 by 4 inch square in the question. We can see diameter bolt, and putting on this all the values here, and found r equal to 21.2 keep, and the number of required bolt, total load allowable capacity, which is 70 minus 3, which is 3.3. So we are known the required bolt is 4, but we have been provided in previously 5, so we can see this is okay, this is okay. So provided LE is 1.7 1.75 in given in question in here. So simple single size of the single size shall be 1.75 into 2 into which will be 3.5 inches. And for additional safety beam wire, the capacity we consider LCS equal to 1.35, as we have been found 1.7, we have provided 1.7, but now we are consider 1.35 for our safety purposes. So the required web capacity, total load we have been found dead load plus live load into 70, 70, and divided by 0.335 is a thickness of web, and found 197.2 key per inch. Now we'll go to the same ASD from AISC manual. Then if we consider ASC and LCS 1.57 and LCB 1 into 1 by 4, then the capacity ASD 2. We have been found 208. On the other hand, we have been found the capacity. Okay, let's see. And the beam capacity, beam web capacity of beam web, we have been found 208, and TW thickness of web we have been found 0.335 from AIC manual in previously, where this is 0.335, and in this way we have been found 73.8 keep, which is greater than the applied load. So our applied load, dead loads plus live load, which is 70, but the section capacity is greater than 70, which is taken from 73.9, so it is okay. So beam we have been used FY50 and angle FY36, thread N which is used 32 35 and F1 36, thickness based on 1 by 6, and bolt angle strength ASD 33.3. Which is greater than the total dead load or live load. So thickness of the angle 1 by 4 we have been taken. So allowable strength for bolt and angle combination, which is greater than 83.3, which is greater than 70, so it is okay. So our last chosen angle L 30 L 3.5 we have been taken here, the 3.5, and 3.5 into 1 by 4 we have been taken here, the 1 by 4, and Fy equal to 36. So let's see another example. So last we have been completed beam to beam or beam to girder. Uh, we have completed beam to girder connection. Now we'll see the beam column connection. So let's see. Uh, W18 into 71 beam is 50 grade, has 2 tons per 75 keep feet dead load and 140 keep live load. The moment to be W21 210 column is strongly axis through the extended in plate type of connection. So it is called also moment connection design. It is also moment connection design, you can and call moment connection design. Moment connection design. Okay, and suitable for diameter of in plate and that determine the bolt diameter and thickness of the plate. Use STM 3 to 5 bolt. So here is the column we can see here. At first we have been taking the some picture as a column. Here is a beam or girder. Okay, so column is given here and this is the beam, so we have to connect this here, and all the dimension of is given here. You can see 12.6 and 7.64 and 0.90. So initially assume 2 row of bolt, we have been 4 row bolt, we have been assume the 4 row 1 2 3 4 bolt configuration, and M is given 1.2 dead load plus 1.6 live load, which is at 3576 inch keep inch. M equal to M factored by we have been used LRFD method. The moment will be moment equal to flange tension force into lever arm. So how we'll get the lever arm? Lever arm is nothing but this is the distance of H, which is 18.5. This is the lever arm. So we can see how we'll get this. We'll found from the beam the beam section, which is W18 by 17. So 18 is the beam section, that's why you will 18.5. This is the lever arm 18.5. And in this way from the flange tension force 194 keep. So tension per bolt it will be 194 divided by 4, as we have been assumed the 4 row bolt, and we have been found 48.5. So stress force per area, as we know, and we have been used, and in this way dB we have been found 0.9 inch, which is we have been taken 1 inch. And K, we know the K value of K 1 into 1 by 5, but we have been taken a value of K which is 21 divided by 16. So if we calculate here 21 divided by 16, so it will be 1.31. Okay, so the K value will be 0.52 or 0.5 to 1.15. So we are taking just 1.3. If the unbraced, then we can use is below, the K value will be below. If the braced, then the K value will be greater than 1. Okay, G1 we have been taken 1 plus K plus 1, we have been taken here 4.62. And G2 we have been calculating here and found 3.5. So maximum we have been taking the maximum value is 4.63, so we will govern the maximum value. Now we are calculating H1. How we will get the H1? So we have been seeing the H1 equal to H minus 1.5 dB minus TF, and found 16.19. And H0 equal to H plus 1.5 dB and found 20. So D0 will be calculated H0 minus TF divided by 2 and found 19.6. And D1 will similarly H1 we have been taken H1 is 16.9 and TF divided by 2 and found 15.8. and dn equal to node d naught into d1. So we are adding two value and found 13 5.4. So bf equal to g plus 2 into 1.5 into db, which is 7.63. So df we have provided in flange 7.63, but we have calculated 7.64, and we have found the 7.63, so it is okay. So we know here we have been we have been used 7.664. We have been seen here in the question we have been used 7.64, but we have calculated for 7.63, so this is okay. So now we calculate in dB root over 2 into m phi p pi phi fy into dn, and found 0.976. So we have been provided in 1 inches, but we have been calculated found 0.96, so it is okay also. Now from bottom, from fc phi board chart, we get s into root over bg into g 7.64. bf equal to from found 7.64, we have been used here 7.64, and 4.63 into g we have been taken 4.63 g, and for 2.97, and p equal to 1.5 into db, which is 1.5. So 2.97 is greater than 1.5, so we have been seen 2.97 is greater than 5. So now we will using the value of s. So we know the value y equal to where we have been seen here, y equal to bf into hy 1 minus pf into s. So s not into 1 minus pf into s. So we will using the value of s. Okay, let's see. 2g equal to 2f into s we have been seeing here, and putting all this value as s equal to 2.97, we have been seeing here the value of s is 2.97, and found 143.34. Okay, for extended plate y gamma r equal to tf equal to 1.1 gamma r pi ampere and phi fy into r, and putting all this value in 1.01, which is 7/8. So total length we will calculate 1.5 into dB plus h naught plus 1.5 into dB, and found 22.7. So we can see the all the parameter is given 7/8. We have been found in TP. Here is a 7/8, and the total length we have been seen the 22.6. Here is a 22.6, and 7.64 we have taken the first line as you in the graph we have been seen here. Here 7.64, and four row and two column we have been taken in bold. That's why we are using this. This is our final diagram. So let's see another example. So it is completed. You can say moment connection or beam column connection. Now we'll so the connection design beam or base plate, beam or footing, which is the base plate design. So now we'll see the base plate design, how we'll calculate his. So let's see. The question is given here. A W44 in 159 column is transmitted on axial compression live load to 750 kip, and dead load is given is 300 kip to a connected base having a top surface area of 35 inches by 7 inches. Okay, so we have been seen here is a 70 inches and 35 inches is given here, and the column dimension is given for W14 into 159, and that those liability is given. Determine the size of thickness of the base plate. So we have to using this we are determine the base plate at 36 material, and concrete use apron C4 use the ASD method. So when you know the W14153, then we can use BF and D from AIC manual. We have been seen here as per from we can use this chart. and found there. Now this is the important. Assume, we have to assume a2 minus a1, which is 2, we are assume. So but the value will be must be less than 1.2. We will assume trial one 2 times. We'll assume again and again, or this is as a trial error method. So fp equal to 0.85 f times a1 by a2 ratio we have been taking 2 and found 6.8 ksi. And dead loss plus livelihood we have found 1050 keep. And we know force equal to stress equal to force per area, and putting on value and found a equal to 19.65 into 19.65. So b into n equal b 19.65 into 9.6. So we are checking the our assumed value on divided by ratio of a1 divided by a to square root. So we have been found 1.77, but we are assumed to but we have on the other hand we are calculating for 1.77. So this is not okay. Now we are assuming again which is value is less than 2, or is compare or the which is very close to 1.77. Now we are again assume ratio square root over a1 divided by a2 is 1.7, which is 1.50, and calculating all the parameters stress 51 and same as stress equal to force per area, and found area equal to 22.68 into 22.61. So this is the value of b into n. And the checking the area, which is 35, we have been found area, and a1 equal to 22 into 75 into 22 into 75. We are checking this by using here. And 35 we have been used. Why you are using 35 here too? Because we have been used this in the found from base plate. We are taking in is given in question, or given we are using this base plate in 35. That's why the previous 35 is remain same. So the 35 will remain same, but the change will be a the value 22.75, or we have been found 19.65. And we have been found 1.54. So we are assuming 1.50, and check value have been found 1.54. So this is okay. So dimension is okay. So now we can see here n equal to 0.50 b into 0.80 bf, and found 5.135, and m equal to 0.50 and minus 0.90 into t, which is found 4.25. And we have done we can see m into m maximum of n, which is we have been found, which is the maximum value have been 1 is 0.5 and another is 4. So we are taking the maximum value 5, and this is the value of I. And thickness of base plate, we are not equal to root over 2p into 5fn into bn into I, and putting all this value, and I is we have taken the maximum value from here, and found 2.22, and we are around about 2.25. So the base plate, we have the size b into n, we are taking 22.75 and 22.75, and now we are taking the thickness, which is 2.25. So this is our last this is our final, which is a base plate design. B we have been found 22.75 and n equal to 20.75, and thickness into 2.25. So this is we have been found, and this is the B, which will be 22.75 and n equal to 22.75, and thickness we have been taken 2.25. So if we shaded line, this will be base plate, this will be base plate, this will be base plate. On the other hand, we can see the 17 into 35. 70 into 35 is we can see the footing dimension, so we cannot change this. Okay, so if you have any question, so in this way you can design the base plate also. So first of all, I am design the beam or girder to girder design, then beam and column design, then column and base or base plate design. So I'm seeing you the three type of design. If you have any question, then let me know. I will try to explain again. Thank you everyone. Thank you.